Is anyone else seeing my confidential sales data? This question kept a financial services client awake at night until we implemented proper row-level security in their Microsoft Fabric environment. Welcome to part 4, the final installment of our DP-600 exam prep series. Today, I'm showing you exactly how to secure your data, so the right people see only what they're supposed to see. If you've been following along, you won't want to miss this crucial finale. Make sure to subscribe for more certification prep and Microsoft Fabric expertise. The hidden risks of unsecured data. What if your team's sensitive sales data was visible to everyone? Imagine this scenario. Confidential financial records, customer details, and internal performance metrics that should only be accessible to a handful of decision makers are now open, seen by employees, contractors, and even external partners. Without proper safeguards, this isn't just a nightmare, it's a reality for many organizations. Whether it's a deliberate act or accidental misconfiguration, unsecured data can lead to costly repercussions. Let's consider a scenario many companies face. A global retail corporation handling millions of sales transactions every week suffered severe reputational damage due to a simple oversight in their analytics platform. They relied on shared Power BI reports to communicate KPIs across teams. Unfortunately, these reports lacked properly defined security measures. A junior employee, while analyzing sales trends, unintentionally accessed salary and bonus details allocated to other departments. This wasn't sensitive data the employee could act on, but it sparked unwanted discussions and eroded trust within the organization. For a larger company that's also bound by strict data privacy laws, the potential fallout is far worse. Breaches like this one invite compliance penalties and massive financial losses. The problem boils down to one thing: no row-level security. When row-level security isn't implemented, the system fails to monitor who is accessing what. It's like leaving your home with every door wide open. In analytics terms, this means that if an employee is given access to your Power BI workspace and decides to explore reports or underlying data tables, they might stumble upon content they have no business seeing. Sensitive details like revenue splits, client credits, or employee ratings stored at the row level are now available to anyone with basic viewer access. This creates an unpredictable environment where trust in data confidentiality is shattered. Here lies the broader issue. Organizations recognize the importance of gathering and analyzing data. Yet they often overlook the safeguards that ensure data is only seen by the right people. Data breaches aside, such access violations also undermine internal accountability. Employees may question why a contractor knows about annual projections or why someone on a different team has insight into a region's client churn rate. A lack of trust grows among staff, and worse still, leadership can no longer rely on secure analytics to make informed decisions. To solve this, companies need to control access down to the most granular detail. Row-level security, referred to often by its acronym RLS, is the answer. This feature empowers organizations to restrict data visibility within Power BI reports by specifying permissions at the row level. Think of it this way: RLS acts as a gatekeeper. It identifies each report viewer and ensures they only see the rows relevant to their role, department, or region. Here's an example of how RLS works in action. A Power BI report may contain sales data for regions across the country: Northwest, Southeast, and Midwest. A regional manager from the Northwest should only be able to view figures tied to their territory, even if the data for the entire country exists in the file. RLS assigns rules to enforce this by utilizing a feature called the user principal name, which checks the email username of anyone logged into a report. It automatically determines which rows to show based on that person's assigned security role. This keeps critical data insights flowing while keeping the wrong eyes out of sensitive details. Now, why is this feature so crucial? Beyond just blocking unwanted access, row-level security helps businesses comply with critical regulations like GDPR or HIPAA. These laws don't just suggest that data privacy is a good practice, they require it. By implementing RLS, companies proactively protect themselves from legal troubles that arise when sensitive information is accessed without proper authorization. The system itself ensures compliance is baked into daily data consumption instead of relying on manual oversight. It's also worth mentioning how RLS works seamlessly within the Microsoft ecosystem to enhance team collaboration. For organizations already using Microsoft Fabric or Power BI as primary business intelligence tools, deploying RLS isn't a complicated task needing drastic infrastructure shifts. Instead, it integrates directly into the workspace where your teams already view reports. Managers get to control team-specific insights without the need to distribute different versions of the same report. By reducing redundancies and mistakes, businesses can scale operations with confidence that their data remains both accessible and secure. Let's revisit our earlier example, the retail corporation that faced an internal trust issue. Once they adopted RLS, the dynamics shifted. Through user-defined roles and filters linked to employee IDs, each department only saw numbers relevant to their area of focus. Finance could merely deep dive into scorecards without anyone outside their department seeing sensitive ratios or compensation data. Meanwhile, sales teams functioned with competitive clarity, using tools that, to them, felt intuitive and comprehensive. Adopting proper security measures like this doesn't just fix past mistakes, it prevents them in the future. Another critical aspect is how this system encourages auditability. With granular role-based assignments, it's easy to not only track who has access to what, but also ensure workflows remain transparent and traceable over time. This simplifies troubleshooting when something feels off, leaving teams with fewer mysteries and more clarity. Row-level security does more than plug data leaks. It fuels confidence among users. Once employees believe the data they interact with isn't accidentally cross-polluting with unrelated areas, they naturally trust these tools more. This improved trust translates into better usage rates across your Power BI platform, enhancing productivity and decision-making across the board. Now, as powerful as row-level security is, there's a catch. It's incredibly effective, but only when implemented correctly. Misconfiguring rules or rushing to set up roles can lead to oversights which might create loopholes in your system. Fortunately, Power BI offers clear paths to implement RLS reliably. Save yourself trouble by carefully designing roles within Power BI Desktop, testing how these security layers work across user groups, and ensuring reports are always linked with relevant permissions before publishing. One of the standout features of RLS is how tailored it can go. Want to restrict employee views to single-row historical data summaries and not dynamic dashboards? Easy. Need to grant broader access only to upper management without allowing data exports? Done. Its flexibility makes it applicable across industries, whether for healthcare, retail, or financial services. This universality reinforces why so many businesses today see it as essential. But our exploration of securing Power BI doesn't end here. In the next section, we'll move beyond rows and dive deeper, literally into restricting access to entire columns or even entire tables. If you've ever asked yourself, is it possible to lock off sensitive tables without impacting related data models? You're not alone. Tools like Tabular Editor take this type of granular control to the next level, and implementing it may entirely change how your organization handles sensitive analytics structures. Stay tuned to see how object-level security reshapes advanced Power BI protection. Row-level security, the game changer for data protection. How can you ensure that the right data reaches the right people and only them? That's where row-level security or RLS comes in. At its core, RLS is a feature within Power BI that allows you to customize data visibility at the most specific level, the rows. This means you can control exactly who sees what in your reports, ensuring sensitive data stays protected while relevant insights are shared with the appropriate users. Let's break this down into practical terms. RLS operates by using conditions, typically defined through DAX expressions, to filter rows of data based on the user accessing the report. A common example is matching the currently logged-in user's email address, also known as their user principal name, to a specific value in the dataset. By doing this, Power BI determines which rows the user should see, hiding everything else. This makes the data experience highly personal and secure, ensuring that no one has access to information they don't need. For instance, in a sales report for a national company, you may have a dataset containing sales figures from every region. Without RLS, anyone with access to the report could see all rows, including data from regions they have no involvement with. By applying RLS, you can ensure that the sales manager for the Southwest region only sees rows tied to their region. This is done by creating a DAX filter using the region column in the dataset, restricting what each user can view based on their regional assignment. Now, how do you actually implement RLS in Power BI? It starts with Power BI Desktop. First, you need to create roles within the Manage Roles option. These roles act as containers for your security filters. Let's assume we're working on a sales dataset with a salesperson email column that you'll use to filter permissions. After creating a new role, you select the appropriate table, in this case, the sales table, and write a DAX expression like salesperson email a user principal name. This expression compares the email stored in each row with the email of the currently logged in user. If there's a match, the user sees the data. If not, those rows are hidden. After assigning the DAX expression, it's crucial to test your setup. Power BI Desktop has a feature that allows you to view the report as a specific role. By simulating different users, you can confirm that the applied filters are working correctly and users are only seeing the data that's intended for them. Skipping this validation step could result in users gaining unintended access or missing key data. Once everything looks good in testing, you can publish the report to the Power BI service, where the roles you defined will automatically enforce security for all viewers. The benefits of this level of control are immense, especially when dealing with sensitive or competitive data. For example, imagine a sales report shared with a team of field agents. Without RLS, every salesperson can see everyone else's performance data. Not only is this a privacy concern, but it could also lead to friction within the team. By implementing RLS to restrict each salesperson to only view their own sales, you maintain privacy, reduce distractions, and ensure that everyone is focusing on their work without comparisons. Now, let's take a moment to differentiate row-level security from object-level security. While RLS works on rows of data within a table, object-level security controls access to entire tables or even individual columns in your dataset. These two features work towards the same goal, data protection, but their use cases differ. For instance, while RLS is ideal for cases where every user interacts with the same table but needs filtered access, object-level security is better suited for completely hiding sensitive data structures like a table containing employee salaries. Think of a scenario where your dataset includes a table containing confidential HR data like salaries or medical insurance records. In this case, object-level security allows you to hide the entire table from unauthorized users so they don't even know it exists, let alone access it. This enhanced control comes with its own tools, such as Tabular Editor, which we'll discuss in the next section. But for now, remember that while these two types of security serve complementary purposes, the distinct way they target access by row versus by object makes them powerful together. Returning to our example of a sales report, the advantage of RLS is its adaptability. Using DAX expressions, you can create a range of filters tailored to your organization's structure. Need to assign RLS based on department instead of individuals? Simply modify your filter to something like department equals selected value, department table, department. This flexibility allows businesses to scale their reporting needs without compromising security. It's just as useful for a small team handling regional sales as it is for a multinational corporation governing its global operations. Another strength of RLS lies in how seamlessly it integrates with existing Power BI workflows. There's no need to create separate report versions for each user group, a practice that's prone to errors and increases maintenance overhead. Instead, a single report can dynamically adjust its visibility based on who is logged in, simplifying management for administrators while providing a consistent experience for users. But even well-implemented RLS comes with limitations. It's rule-based, meaning its accuracy depends on the quality of your filters. If the DAX expressions contain errors or your data isn't properly organized, unexpected visibility issues can occur. For example, let's say your dataset includes rows where the salesperson email column is blank due to missing data. In this case, a user might suddenly see rows they shouldn't, or none at all. Anticipating and addressing such edge cases is an important part of RLS setup, and this is why validation can't be skipped. One of the most common questions is whether RLS impacts performance. The short answer is that it can, particularly for large datasets with complex rules. Every time a user accesses the report, RLS must check the filter conditions for each row they are authorized to view. While Power BI is optimized to handle these processes efficiently using overly intricate DAX expressions or stacking too many rows can slow things down. Keeping your data models clean and your RLS rules straightforward helps maintain smooth performance. This brings us to tools that complement RLS. Tabular Editor, for instance, provides advanced customization options for both row-level and object-level security, enabling greater flexibility in defining your filters and roles. If your organization handles large, multi-layered datasets, Tabular Editor can simplify the management of security rules across these models, giving you better control over performance and accessibility. We'll explore this tool further in the next section, but for now it's worth noting how auxiliary tools can enhance what RLS already does well. In the end, RLS adds a layer of trust to your Power BI environment. Employees using these reports know they aren't being exposed to irrelevant or sensitive data, while administrators retain confidence that compliance requirements are being met. It's not just about controlling access, it's about creating a system where users feel secure engaging with the data. As powerful as RLS is, keeping your datasets fully protected often requires combining multiple security techniques. This is where object-level security steps in, taking protection beyond individual rows to entire tables and columns. Imagine being able to lock down sensitive information or ensure that high-level metrics stay hidden from broader teams with a few additional configurations. In the next section, we'll discuss how these advanced controls work, focusing on when and why you'd use object-level security and how tools like Tabular Editor expand your ability to secure Power BI datasets. Object-level security, going beyond rows. What if you could restrict access to entire tables or columns in your dataset? Sometimes row-level security isn't enough. There are scenarios where it's not just about filtering rows of data within a table, but completely hiding certain elements of your data model. Whether that's sensitive tables with private financial information or columns containing personally identifiable information like social security numbers. This more advanced form of data protection, known as object-level security or OLS, ensures that you're not just limiting what data people see, but entirely controlling which parts of your dataset they even know exist. So, what is OLS exactly? Unlike row-level security, which dynamically filters visible rows based on a user's identity, OLS operates at a higher level. With this tool, you control whether specific tables or columns in your model are visible to certain users or entirely invisible. Imagine you're working with a dataset that includes a table storing employees' salary details. Not only do you want to hide the actual data rows in this table, but you want to ensure no one outside the HR team even knows the salary table exists. OLS goes beyond merely restricting access. It erases the table's presence from the user's view altogether. It's not there. This approach can prevent users from even suspecting sensitive data is part of the model, making it an effective way to comply with privacy requirements and protect critical business information. Now, here's the challenge. You might assume you can configure OLS directly in Power BI Desktop, but you can't. Unlike row-level security, which can be implemented natively within Power BI Desktop's interface, OLS requires a more specialized approach. That's where Tabular Editor steps in. Tabular Editor is an external tool specifically designed to handle features like OLS by connecting to your model and offering a deeper level of access and customization. Power BI Desktop alone doesn't provide. It's widely relied upon by professionals for its advanced capabilities in managing roles, permissions, and optimizing models. Let's go step by step to understand how you would set up OLS using Tabular Editor. It starts, just like with row-level security, by defining roles. You might establish these roles directly within Power BI Desktop beforehand, if that's your starting point, or you can create them within the Tabular Editor interface itself. Once the roles are created, the next step is to open your dataset in Tabular Editor. This process connects the editor to your Power BI model, allowing you to make direct adjustments to the metadata. including defining OLS settings. Once you're inside Tabular Editor, you'll work with the table properties to control access. Let's go back to our earlier example, the sensitive salary data table. To make sure only HR staff can access this table, you'd select the role associated with HR and navigate to the specific properties of the salary table. Assigning permissions is straightforward. You choose between none, which denies all access to the table for that role, or read, which allows viewing. For non-HR roles, selecting none makes the table entirely invisible. What does that look like in practice? If a report is built using data from the salary table, users outside the HR team would receive no data or even an indication that the table exists. The system effectively makes that sensitive portion of your dataset disappear. OLS isn't limited to just tables. You can implement these security rules on individual columns within tables as well. This is particularly useful when you need to share most of the data in a table but keep certain fields confidential. For example, think of a table containing payroll information that includes basic details like employee names, payment dates, and total salaries. While everyone on the finance team might need access to the payment dates and names, perhaps only the payroll manager should see the exact salary amounts. Using Tabular Editor, you select the specific salary column and configure its visibility settings based on defined roles. This way, the column won't show up even as an empty field for users without the required permissions. It's important to mention that once you've tailored your OLS settings in Tabular Editor, the work isn't done. These settings need to be deployed and enforced through the Power BI service. After publishing your dataset to the service, you must assign users or groups to the roles you created. This step is critical because it's what enables Power BI to apply the security configurations when users interact with your reports. Without this last step, users might end up seeing data or objects you intended to restrict, making all that work in Tabular Editor pointless. By carefully assigning users to roles, you gain precise control over how your data is accessed, ensuring no unauthorized entry points remain. Here's an example of OLS in action to emphasize how transformative it can be. Let's say you're working for a healthcare organization that stores detailed claims data. One part of your team handles claim processing and needs visibility into procedural details such as service dates and claim statuses. But within the same dataset exists a table containing detailed diagnosis and patient health records, information covered under strict confidentiality rules like HIPAA. Implementing OLS, you'd assign the processing team a non-permission level for the health records table. They'd still interact with the procedural claims data they need, but would have zero awareness of the sensitive records table existing within the dataset. This approach ensures compliance with data privacy laws while maintaining operational efficiency. OLS doesn't just protect sensitive information, it can also streamline reporting environments by decluttering the user experience. Consider this. The fewer unnecessary tables and columns users can access, the less overwhelm they face when navigating complex reports. For example, if a sales department only requires product-related information, there's no reason for them to scroll through unrelated data structures like marketing budgets or supplier details. Hiding these elements using OLS not only safeguards data but also reduces cognitive load, allowing users to focus on relevant insights. As powerful as OLS is, there are important limitations to keep in mind. Because it operates outside Power BI desktop, the extra step of configuring it in Tabular Editor and managing roles in the Power BI service requires additional expertise. Teams unfamiliar with Tabular Editor might face a learning curve. Additionally, implementing OLS can introduce inefficiencies if done poorly, for example, overly intricate permission structures that are difficult to maintain. This highlights the importance of planning your security model thoughtfully to avoid creating a web of permissions that becomes a headache to manage later. Another critical point is OLS's reliance on clean and consistent metadata. If your dataset contains scattered or mislabeled information, poorly defined relationships, or tables that mix confidential and non-confidential data, setting up OLS becomes problematic. For example, if sensitive salary information is scattered across multiple tables instead of being neatly contained within one, enforcing OLS may require configuration across numerous objects, which increases the risk of oversight. Cleaning up your data model beforehand ensures you can implement OLS efficiently and effectively. Despite these complexities, OLS is an essential tool for organizations that deal with sensitive data. It provides a level of control that row-level security simply can't match. By restricting entire objects, you significantly reduce the risk of accidental exposure. This makes OLS particularly critical for industries like finance, healthcare, or retail, where regulatory compliance and data integrity are paramount. The addition of OLS to Power BI's security options also deepens trust within organizations. Team members can confidently access and analyze data without worrying about seeing or mishandling information beyond their scope. Leaders, meanwhile, gain peace of mind knowing that sensitive data sets are fully protected and only available to those who genuinely need access. Now that we've explored the power of OLS, it's time to expand the conversation into how performance optimization tools can further enhance your data models. While security is crucial, it's only one piece of ensuring your datasets serve users efficiently. Tools like VertiPaq Analyzer dive into the underlying structure and performance of your models, helping you pinpoint inefficiencies that slow down processing times or increase resource usage. In the next section, we'll explore how leveraging these tools can help you not only secure but also supercharge your reports for faster queries and smoother analysis. Incremental refresh, the key to faster data updates. What if you could refresh only the data that's changed instead of everything? For anyone working with large datasets, the frustration of running full refreshes is all too familiar. Whether you're analyzing millions of rows in a fact table or processing daily transactional data, refreshing the entire dataset can be inefficient, resource-draining, and frankly time-consuming. That's where incremental refresh, one of Power BI's most powerful features, comes in. By focusing only on the data that's been added, updated, or changed within a specified time frame, incremental refresh allows you to dramatically improve refresh speeds and resource efficiency, perfect for large-scale datasets or time-sensitive analysis. So how does incremental refresh work, and why is it such a game changer? Let's start with the basics. In traditional full refresh scenarios, Power BI reloads the entire dataset every time you initiate a refresh. Even if only one day's worth of data has changed, the platform still pulls in weeks, months, or even years of historical data all over again. For large fact tables with millions of transactions, these refreshes not only slow down reporting but also place heavy demands on your system resources. Long refresh times increase the chance of timeouts, particularly for cloud-based data sources, which can create bottlenecks in the availability of updated reports. Incremental refresh changes this paradigm by doing something much smarter. Instead of refreshing everything from scratch, it works incrementally, hence the name. It identifies and processes only the data that falls within a set timeframe, such as records modified in the last 7 days. Older data, which remains unchanged, doesn't get touched, cutting down the workload considerably. But here's the key. Incremental refresh isn't some one-size-fits-all feature that works out of the box. It requires configuration within Power BI Desktop and only functions for users of Power BI Premium licenses, including Power BI Premium per user, PPU. Setting up incremental refresh involves a few steps, and the most critical part is defining your parameters. The process begins in Power BI Desktop with the creation of 2 reserved parameters called range start and range end. Why these names? Power BI uses them as system keywords during configuration, so they must be spelled exactly as required for the feature to work. Both parameters act as dynamic placeholders for the date range of the data you want to load. You'll typically use these parameters to zero in on recent updates, for example, transactions from the 1st of the current month to today. After the parameters are set, the next step happens in Power Query Editor. Here, you filter your dataset using the range start and range end parameters. Let's say you're dealing with a sales database. You'll create a custom filter on the sales date column, instructing Power BI to include only rows where the date falls between the range start and range end values. This does 2 things. It limits the data to only the range you care about, and it sets the foundation for defining the refresh policy itself. The result is a highly efficient process that skips untouched rows entirely, focusing solely on what's new or recently modified. Once the filter is configured, it's time to establish your incremental refresh policy. Power BI allows you to set how far back it should import historical data when the refresh first runs. This might be the last 2 years of transactional data, for example. You can also define how far back to apply incremental updates, such as refreshing only the last 30 days for weekly updates, or even just the last 24 hours for daily data. Throw in optional features like refreshing only full days or detecting data changes, and the setup becomes even more granular. The key is striking a balance between capturing recent changes and preserving system performance, especially if you're working with high traffic, constantly updated databases. But the real magic happens after the report is published to the Power BI service. Once incremental refresh is enabled and configured, it automatically triggers during scheduled refresh cycles according to your defined policies. For instance, suppose your dataset processes sales data daily at midnight. With incremental refresh, instead of pulling months of historical data every night, Power BI only loads and processes yesterday's transactions. The older data stays right where it is, untouched and ready for analysis. The process is seamless to the end user, who continues to see up-to-date insights without interruptions. The benefits of incremental refresh go beyond faster refresh times. By drastically reducing the amount of data being processed, it also cuts down on resource usage. This means your Power BI environment runs more efficiently and is less prone to issues like timeouts caused by extended data loads. You might previously have been dealing with refresh times that take, say, an hour or more. But with incremental refresh, those times drop to just a few minutes. This freed up capacity can be used for other tasks, such as running complex calculations or improving dashboard visuals. Incremental refresh also enhances reliability, a critical consideration when dealing with business-critical datasets. Full database refreshes often involve long-running connections that are more susceptible to interruptions. Incremental refresh resolves this by keeping data loads smaller and more focused, minimizing the chance of failure. Say goodbye to the panic of finding your dashboard blank on the morning of a big presentation because the refresh timed out overnight. It's a solution that not only improves performance but also reduces stress when you're relying on daily updates. Let's walk through a practical example. Imagine you're managing a data set containing 50 million rows of e-commerce transaction data, spanning several years, stored in a SQL database. Each day, around 10,000 new transactions are added. With a full refresh, you'd reload all 50 million rows every single time, which is not only inefficient but can overwhelm your database server and Power BI system. By implementing incremental refresh, you can configure Power BI to load only the last 30 rolling days for changes while archiving older data that remains static. From then on, it'll pull just the 10,000 new records every day instead of reprocessing your entire dataset. Your dashboards remain responsive, your refreshes run on time, and your infrastructure runs smoothly. It doesn't stop there. Incremental refresh enables teams to analyze data in near real time without waiting for lengthy refresh cycles. For industries like retail or finance, where last-minute insights can shape critical decisions, this makes a significant difference. It opens up the possibility of continuous analysis rather than waiting for batch updates. Another important consideration is how incremental refresh fits into the broader Microsoft Fabric ecosystem. While it's currently a key feature in Power BI, Microsoft has signaled plans to extend similar functionalities to its other tools, such as Data Factory and Dataflow Gen 2. This shows a commitment to streamlining data refresh processes across the board, making it easier for enterprises to scale their solutions while maintaining high performance. With that said, using incremental refresh isn't without its challenges. Misconfigured parameters or poorly planned refresh policies can lead to unexpected gaps in your data. For example, if your range start and range end parameters don't account for your data source's update frequency, you risk missing recent changes or accidentally loading duplicate records. Regularly testing your setup in Power BI Desktop before publishing ensures that everything runs as intended, saving you troubleshooting headaches down the line. There's also the question of who benefits the most from this feature. Incremental refresh works best for organizations dealing with large time-based data sets, such as sales data, web traffic logs, or IoT sensor readings. For smaller datasets or infrequently updated data, the advantages are less pronounced and might not justify the additional configuration effort. But for those working with substantial volumes of constantly changing data, this feature can mean the difference between barely keeping up and staying ahead. Ultimately, incremental refresh is all about efficiency, not just in terms of speed, but also the time it saves you to focus on deeper analysis rather than data management. It represents a shift from brute forcing updates to working smarter with targeted data loads. Faster refreshes mean faster insights, which means better decision-making for you or your team. Speaking of efficiency and performance, there's another layer to optimizing your Power BI performance. Fine-tuning your semantic models. Tools like VertiPaq Analyzer can help you zero in on inefficiencies within your models, uncovering what's slowing things down and how to fix it. In the next section, we'll dive into how performance tuning for data models goes hand in hand with features like incremental refresh, creating a highly optimized and seamless data environment. Diagnosing slow reports, tools you need to know. Is your Power BI report taking forever to load? Few things are as frustrating as watching a dashboard lag or a visual churn endlessly while you're trying to analyze important data. Slow performance in Power BI can disrupt workflows, delay decision-making, and, let's be honest, make the entire reporting experience feel like a chore. One of the most common culprits is inefficient queries, those underlying processes that retrieve and calculate data before it's displayed in your visuals. Yet pinpointing exactly where the slowdown is happening can be challenging within Power BI Desktop alone. Power BI Desktop does include some basic tools to troubleshoot performance, like the Performance Analyzer. It's a helpful starting point, allowing you to record specific actions like filtering visuals or loading pages and measure how long each task takes. You can see a breakdown of query times and visual load times, and even export that data for further review. But here's the limitation. Performance Analyzer within Power BI Desktop is fairly surface level. It might show you that a particular visual is slow, but it doesn't tell you why. This is where relying solely on the desktop tool becomes a bottleneck in itself. For deeper insights into what's really slowing down your report, you'll need more advanced tools. This brings us to DAX Studio, the go-to solution for diagnosing slow Power BI reports. It's an external tool specifically built for analyzing DAX queries, which are the calculations and formulas driving the visuals in your reports. While Power BI Desktop might show you that a query is taking longer than expected, DAX Studio allows you to dive into the actual query itself. It acts like a magnifying glass, exposing what's happening under the hood of your report and giving you the details you need to identify bottlenecks. One of the standout features of DAX Studio is its ability to work with data from the Performance Analyzer. Here's how it works. Once you've recorded performance data in Power BI Desktop, you can export it as a JSON file and import it directly into DAX Studio. This lets you take the high-level breakdown you saw in Power BI and analyze it in far greater depth. For instance, DAX Studio enables you to filter and sort performance logs, which can help you zero in on the most problematic queries. This capability is particularly useful because Power BI's built-in Performance Analyzer doesn't provide much flexibility beyond basic reporting. DAX Studio also gives you access to trace functionalities for analyzing query performance in greater detail. There are 3 key types of traces: all queries, query plan, and server timings. The all queries trace captures every query event that occurs, whether initiated by the user or the system itself. This is helpful for understanding how interactions within your Power BI dashboard, such as clicking filters or slicing data, trigger different calculations. Query plan trace, on the other hand, focuses specifically on the execution plan for a DAX query, offering insight into how the query is structured and why it might be taking longer than expected. Finally, the server timings trace measures the time taken on the server side to process your queries. Together, these traces provide a full picture of what's happening both client-side and server-side, making it easier to locate the root cause of performance issues. Let's look at an example of how DAX Studio can help diagnose a slow report. Imagine you've built a sales performance dashboard. One particular visual, a year-over-year comparison of revenue, is painfully slow to load every time you interact with the slicer. You record the issue in Power BI's Performance Analyzer and discover that the query for this visual is taking over 10 seconds, far too long for something that should feel instantaneous. You export the Performance Analyzer data and open it in DAX Studio. Now, instead of seeing just a summary of the query's time, you can view the actual DAX code running behind that visual. Within DAX Studio, you analyze the query and notice some inefficiencies right away. Perhaps your query uses functions like SUMX on a massive unoptimized column, or maybe it's filtering the entire dataset row by row instead of utilizing clear relationships defined in your model. By making changes to your DAX formulas, like switching to more efficient aggregations or pre-calculated measures, you can cut down the time that query takes, bringing it from 10 seconds to something far more manageable, like 1 or 2 seconds. Another area where DAX Studio shines is in analyzing server-side performance. As your dataset grows larger, the time spent processing visuals on the analysis service's Tabular engine, the backbone of all Power BI models, tends to increase. Using the server timings trace in DAX Studio, you can measure how long the server takes to execute each query. This is especially helpful when the issue doesn't appear to be in your DAX code itself, but instead in how the server is handling the query. For example, you may find that a large table with high cardinality, many unique values, is causing performance degradation. Armed with this information, you might decide to optimize the table structure by reducing cardinality, breaking it into smaller tables, or summarizing its data at a higher level. Once you've identified and fixed performance bottlenecks using DAX Studio, you can bring those optimized queries back into Power BI Desktop. One important note here is that DAX Studio is a read-only tool for Power BI models, meaning that while it lets you analyze and troubleshoot issues, any updates or changes to your queries need to be made manually in Power BI. This process might feel a little hands-on, but it's the trade-off for having such a powerful diagnostic tool at your disposal. One more thing to highlight is how DAX Studio integrates with other advanced tools like VertiPaq Analyzer. While we'll cover VertiPaq more in depth later, it's worth mentioning here that DAX Studio includes built-in features to analyze the size and efficiency of your semantic model. You can use it to see how much memory each table, column, or measure is consuming, which provides additional clues about what might be causing slowdowns in your report. For example, if a single column is taking up disproportionately large memory because of high cardinality, you'll know to focus your optimization efforts there. Now, performance tuning isn't just about fixing what's broken, it's about building efficiency into your reports from the start. A tool like DAX Studio helps you understand how different elements of your model interact and affect performance, giving you insights you can use to design smarter queries and better optimized models moving forward. Think of it as an essential step in mastering Power BI at an advanced level. To wrap up, tools like DAX Studio fill in the gaps where Power BI Desktop's troubleshooting capabilities fall short. By giving you deeper visibility into queries, server timings, and execution plans, DAX Studio equips you with the knowledge to not only resolve performance issues but also build better models in the long term. Slow visuals and lagging reports don't have to be your reality. Diagnosing and optimizing your reports is completely achievable with the right tools and techniques. Of course, diagnosing performance issues is only half the battle. Once you've identified the problem areas, the next step is optimizing your models to ensure peak efficiency. In the next section, we'll dive into how tools like VertiPaq Analyzer and Tabular Editor can help you fine-tune your datasets, reduce load times even further, and make your Power BI models run like a well-oiled machine. Stay TNED. Data models that fly. Optimizing with VertiPaq and Tabular Editor. What's hiding in your data model that's slowing everything down? Most issues with slow Power BI reports aren't caused by fancy visuals or heavy-duty calculations. They're buried in the structure of your data model itself. Tables that are too big, relationships that aren't optimized, and inefficient data types can all weigh down performance, increasing load times and degrading the user experience. But identifying these hidden issues isn't always simple. That's where tools like VertiPaq Analyzer and Tabular Editor come in. They help you uncover what's underperforming in your semantic model and give you the insights to fix it. Let's start with VertiPaq Analyzer. VertiPaq is the in-memory engine that Power BI uses to compress, store, and calculate data. It's incredibly efficient when applied correctly, but improper model design can overwhelm the engine and cause performance bottlenecks. VertiPaq Analyzer is a diagnostic tool that connects to your Power BI model and provides a detailed breakdown of what's happening inside. Think of it as an X-ray for your model. It examines the underlying metrics like table sizes, the number of unique values in a column, cardinality, and how relationships are managed. One of the most useful insights from VertiPaq Analyzer is table size analysis. When you load a dataset into Power BI, tables are compressed by VertiPaq to save memory, but some tables grow disproportionately large if they contain too much granular data or high cardinality columns. Imagine a transactional dataset with hundreds of millions of rows and a timestamp column recording every second. Without any optimization, this column can balloon in size due to the sheer number of unique values. In VertiPaq Analyzer, you'll see exactly how much memory this column is consuming, making it clear that it's an issue. You can then optimize it by rounding timestamps to the nearest minute or hour, significantly reducing cardinality without losing meaningful data for analysis. Another powerful insight from VertiPaq is its ability to identify referential integrity violations. These occur when a relationship between two tables breaks down because the unique keys don't match. For example, say you have a table of customer orders linked to a product lookup table, but some orders reference products that were deleted from the lookup table. This mismatch not only creates data inconsistencies, but can also slow down the model because Power BI still tries to process the broken relationships. Using VertiPaq Analyzer, you can spot these violations and clean up the data to maintain integrity. Columns often present another opportunity for optimization. VertiPaq Analyzer allows you to examine column statistics, like their data type and encoding method, to determine where inefficiencies might lie. Text columns, in particular, can be problematic since they use more memory than numeric columns. For instance, if your sales table includes a product name column with thousands of unique entries, converting it to an indexed integer column or even replacing it with a product ID can reduce memory usage while maintaining the same functionality. By analyzing these details, you're not just cleaning up your data model, you're also helping Power BI use its resources more effectively. Now, while VertiPaq Analyzer gives you a clear picture of your model's performance, fixing the problems often requires another tool, Tabular Editor. This powerful application is designed to help you build, manage, and optimize Power BI datasets beyond what's possible in Power BI Desktop. Tabular Editor doesn't just let you interact with your model, it provides automation and advanced features you won't find anywhere else. One standout feature of Tabular Editor is the Best Practice Analyzer, BPA. It's like a checklist for the health of your dataset. The BPA scans your entire model for common issues based on predefined rules, which are split into categories like DAX performance, model design, formatting, and error prevention. These rules, freely available on platforms like GitHub, not only identify performance bottlenecks but also offer actionable recommendations to resolve them. For example, the BPA might flag an issue with your calculated measures. Other tools won't tell you that some of your DAX formulas reuse unnecessary filters or create overly complex calculations, but the BPA will. It categorizes these issues into severity levels, informational flags for minor adjustments, warnings for potential slowdowns, and errors for critical fixes that could significantly impact performance or data accuracy. By addressing these flagged issues, you're not just making your report faster, you're ensuring your data model is reliable and easier to maintain in the long run. The Best Practice Analyzer doesn't stop with simple checks. It's also fully customizable, meaning you can create your own rules to fit the unique needs of your organization. For instance, you might establish a rule to ensure that every dimension table is formatted cleanly with readable column names for end users. Or you might enforce a naming convention for calculated measures so your team can work more cohesively. Being able to tailor the BPA ensures your semantic model isn't just compliant with general best practices but aligns with your specific goals. Tabular Editor also helps streamline workflows by integrating these best practices into automated processes. For example, the BPA can be run using Tabular Editor's command line interface, CLI, which makes it part of your development pipeline. If you're deploying a semantic model from a development environment to a testing or production environment, the BPA can automatically check for errors before deployment. This automation ensures that the model being used by end users has already been vetted for quality, preventing performance issues from appearing in live reports. Let's step back to see how this works in practice. Imagine you're working with a database that tracks inventory for a national retail chain. Each store uploads daily logs that include details on product sales, stock levels, and shipping schedules. Your Power BI dataset spans millions of entries across dozens of tables. Using VertiPaq Analyzer, you discover that the product descriptions column alone accounts for 20% of the model's memory footprint, an issue due to its high cardinality and reliance on plain text instead of numeric identifiers. You fix this by replacing the column with product IDs and moving descriptive details into a lookup table, cutting memory usage significantly. Next, you open the model in Tabular editor and run the best practice analyzer. It flags the DAX formula behind a key performance indicator, KPI, indicating that you've nested two unnecessary calculate functions instead of performing the filter operation directly. After simplifying the logic, you notice an immediate improvement in how quickly the KPI loads in your report. The BPA also catches a smaller issue. Several columns in your tables are marked as both hidden and unused by visuals, meaning they aren't serving any purpose. By removing these columns altogether, you not only reduce memory consumption, but make the dataset cleaner and easier for your team to navigate. Once these fixes are complete, you redeploy the model using the BPA's CLI integration, ensuring that everything adheres to your internal quality standards before it goes live. What's the impact of all of this optimization? For one, your reports load faster, often in seconds versus minutes, because fewer resources are wasted on processing unnecessary data or inefficient queries. Your team spends less time troubleshooting slow dashboards or waiting for visualizations to update, meaning they have more time to focus on analyzing the insights. And since the data model follows consistent best practices, it's easier for new team members to pick up and use effectively. Beyond performance, an optimized data model enhances report reliability and decision-making across the organization. When measures are written efficiently and tables are properly structured, you lower the risk of inaccuracies creeping into your outputs. A fast report might earn you compliments, but a reliable one builds trust in your process. This trust is what enables stakeholders to use Power BI as a cornerstone for making critical decisions. While both VertiPaq Analyzer and Tabular Editor are immensely powerful on their own, their real strength lies in how they complement each other. VertiPaq pinpoints inefficiencies and hidden resource expenses, providing you with a detailed diagnosis. Tabular Editor steps in to help you fix these issues efficiently, with tools like the BPA guiding the optimization process. Together, they make it possible to not just analyze large datasets, but to make them perform like agile, lightweight models. With your semantic model running smoothly, there's one final piece of the Power BI puzzle to consider: the visuals themselves. Even the most well-optimized model can feel lackluster if the visuals don't convey insights effectively. Choosing the right charts and graphs can make the difference between a report that tells a clear story and one that creates confusion. And as it turns out, the design of your visuals can also influence performance if overloaded with unnecessary features. Up next, we'll dive into best practices for selecting and refining visuals that not only enhance your storytelling but also preserve the efficiency of your reports. Choosing the right visuals for impactful analysis. Are your visuals telling the right story or confusing your audience? Choosing the right visual in Power BI can mean the difference between insights that inspire action and dashboards that leave users scratching their heads. But with so many options available, from bar charts to scatter plots, it can sometimes feel overwhelming to know where to start. The key to impactful analysis lies in understanding how these visuals work, what they're best suited for, and how to avoid the most common mistakes that lead to misunderstandings. The role of visuals in data storytelling is straightforward. They allow viewers to see and comprehend data in ways that tables or raw numbers alone cannot. The right visual can highlight patterns, trends, or outliers, making your insights not only clear but actionable. However, this only works if the correct visual is paired with the message you're trying to communicate. For example, while a bar chart is excellent for showing comparisons between categories, using one to show time series data can end up cluttered and difficult to interpret. On the other hand, a line chart excels in this scenario by showing trends over time with ease. So, how do you decide which visual works best for your data? Let's start with one of the most basic but essential visuals: Tables and matrix visualizations. Tables are excellent when you need to present detailed, granular data. They allow users to explore individual data points or compare specific values interactively. For example, a table is perfect for showing monthly sales per region with drill-through functionality to view product-level details. However, tables are not ideal for identifying trends or patterns because they focus on individual data points. A viewer can easily spot that region A made $10,000 in January and $12,000 in February, but they won't immediately notice whether the overall trend is increasing, decreasing, or staying flat. If your goal is to summarize and compare overall performance or identify trends, you'll need a different approach. That's where bar charts and column charts come into play. These visuals work best for comparisons between categories. For instance, if you're comparing revenue by region, a bar chart makes it easy to see which region outperforms others. You can stack these charts to add more layers, such as breaking down revenue by region and product type. However, trying to use them for time series data like weekly sales over a year can quickly lead to overcrowding. This is when you turn to line charts, which are specially designed for visualizing data across time. Line charts allow you to track trends clearly and are easy to read even over long periods. For more complex metrics, combo charts come into play. A combo chart combines bar and line visuals to show relationships between two metrics on the same plot. Imagine you're analyzing sales alongside profit margins. Bars can represent monthly sales totals, while a line tracks the profit margin percentage. This combines two perspectives into one visual, but the challenge here is clarity. Ensure the visual is well labeled, with each axis clearly marked, so viewers understand which metric is represented by which element. Without clear labeling, users might misinterpret your data, which defeats the purpose of using combo charts in the first place. Now let's talk about pie charts, a controversial choice in the world of data visualization. Pie charts, along with their relative, the donut chart, are best suited for showing proportions of a whole. For instance, you might use one to display market share among competitors. However, they come with limitations. Humans aren't great at comparing areas or slices of a circle, especially when the differences are small. If your data contains close values, prioritize bar charts instead, where differences in length are easier to perceive. Pie and donut charts also struggle to communicate trends over time, so they're a poor choice for longitudinal data. In short, use them sparingly and only when highlighting proportions. Scatter charts take the stage when you're analyzing relationships between two numeric variables. These visuals are particularly useful for spotting correlations. For example, in a marketing dataset, you might use a scatter chart to visualize how ad spend correlates with revenue. By adding a third variable as color-coded points or sizing the dots, you can introduce another dimension to your analysis. However, scatter charts can become cluttered and difficult to interpret when too many variables or points are included. They also risk suggesting a causality between variables that might not truly exist, so use them thoughtfully and with proper context. Other visuals like gauge charts and waterfall charts serve highly specific purposes. Gauges are often used for tracking progress towards goals, such as annual revenue targets. Their simplicity makes them effective at communicating how close your metrics are to a defined threshold. Waterfall charts visually track changes over a timeline or by specific categories. For example, you could use one to represent the effect of monthly gains and losses on annual profit. Both are highly focused visuals that offer clarity within their use cases but can confuse viewers when not applied correctly. For instance, applying a gauge to compare multiple metrics at once. It's also worth mentioning custom visuals, which extend the analytical possibilities of Power BI significantly. These visuals, often downloaded from the Microsoft Power BI Marketplace, allow you to create specialized graphics tailored to your needs. They include radial gauges, heat maps, and tornado charts, among many others. While custom visuals expand what you're able to present, they also come with a learning curve. It's important to evaluate whether adding a custom visual enhances comprehension or simply introduces complexity. Sometimes sticking with the basics, like a bar chart or line chart, provides better clarity than introducing a highly complex custom visual for novelty. One underrated feature in Power BI that can enhance analysis is the Q&A visual. This tool allows users to type natural language questions directly into the report, instantly generating visuals in response. For instance, if a stakeholder wants to know total sales by region for this quarter, the Q&A visual can create that chart in seconds, even if they're unfamiliar with the underlying dataset or metadata. While this functionality is powerful, it relies on well-structured data models. Users also need to frame their questions to match the dataset structure, which can sometimes lead to frustration if the expected visual isn't generated. Let's look at some examples of good and bad practices when selecting visuals. A good bar chart example would be a report comparing sales by region with clear labels and sorted values, simple yet effective at highlighting trends. On the other hand, a poorly constructed pie chart trying to show 10 different categories with similar proportions will fail to convey any clear takeaway. Similarly, a line chart depicting trends over several years can easily highlight patterns, whereas trying to achieve this with a table would overwhelm the user with numbers instead of insights. The ultimate goal when selecting visuals for Power BI reports is clarity and comprehension. Every visual should be chosen with the end user in mind. Think about what decision they need to make or insight they're looking for and tailor the visual to meet that specific need. Avoid overloading dashboards with unnecessary graphics or packing too much information into a single visual. Instead, group related insights using separate visuals and ensure that each one has a single clear purpose. The right choice of visualization doesn't just make your report look better. It improves how effectively your audience understands and uses the data. This translates to smarter decisions, faster responses, and greater confidence in the insights you're presenting. Remember, data visualization is about communication. A great visual doesn't just show data, it tells a story that your audience can quickly grasp and act on. While visuals are critical for effective storytelling, they're only one part of the equation. The type of analysis you apply to your data, whether it's descriptive, diagnostic, predictive, or prescriptive, determines how far you can take your insights. In the next section, we'll explore these 4 types of analytics, showing how each contributes to building a complete picture and transforming raw data into actionable strategies for your organization. The 4 analytics that drive business success. How do you go from understanding your data to predicting the future? That journey begins by mastering the 4 essential types of analytics: descriptive, diagnostic, predictive, and prescriptive. Each type builds upon the last and answers progressively deeper and more forward-looking questions, shaping the way businesses operate and make decisions. However, many organizations stop at the first step, descriptive analytics, missing out on the transformative power of the other 3. Let's walk through these analytics types, what they mean, and how you can use Power BI to unlock their potential. Descriptive analytics is where most data stories begin. It focuses on uncovering what has already happened, providing an accessible summary of historical data. Essentially, it answers the question, what happened? Common business examples include tracking sales figures, customer growth, or operational performance over a specific period. In Power BI, descriptive analytics is typically visualized with tools like tables, bar charts, line charts, and area charts. These visuals make it easy to spot trends and identify patterns in your historical data. Take a monthly revenue report, for instance. Using line charts, you could illustrate how revenue performed across the past year, highlighting seasonal spikes during holiday months or dips in slower seasons. Another example could be a report showing the number of customer service tickets received per day. By presenting this information in a heat map visual, businesses can immediately identify peak periods that demand more staff resources or faster response times. These descriptive analytics are foundational, making historical insights clear and easy to interpret. But there's a major limitation here. Descriptive analytics only summarizes and it doesn't tell you why something happened. That's where diagnostic analytics comes in. It digs deeper into the data to explain the causes of certain trends or anomalies, addressing the question, why did it happen? It helps pinpoint specific factors that influence outcomes, allowing businesses to understand the context behind their performance. Power BI supports diagnostic analytics through features like drill downs, drill throughs, and correlation visuals. Imagine you're looking at a sales report and you notice revenue in a particular region dropped sharply last quarter. Instead of just noting the change, diagnostic analytics lets you investigate. Using drill-down functionality in Power BI, you could break the data down into product categories or sales channels to identify what contributed to the decline. Was it a supply chain issue, a decrease in top-performing products? By layering visuals like clustered bar charts with advanced filtering, you can narrow the focus and uncover root causes. For instance, you might discover the drop was localized to one product line, giving you clear direction to adjust inventory or marketing strategies. Despite its power, diagnostic analytics also has limitations. It's backward-looking, meaning it still focuses primarily on explaining past events. For businesses aiming to stay ahead, the next step, predictive analytics, is where things get truly transformative. Predictive analytics answers the question, what's going to happen next? It uses historical data alongside statistical models and machine learning techniques to forecast trends and anticipate future changes. Power BI integrates this capability through its time series forecasting and other analytic features available within visuals. To see this in action, think about forecasting future sales. By leveraging Power BI's analytics pane, you can apply time series forecasting to a sales chart and generate predictions based on historical performance. For example, you might project next month's revenue based on sales patterns over the last 3 years. This allows businesses to optimize inventory, plan staffing, or allocate marketing budgets more effectively. Another use case could involve predicting customer churn. By analyzing historical customer data, like purchase history, engagement levels, and demographics, you can build a report that flags customers most likely to stop using your service. This insight enables your team to act quickly, offering targeted campaigns or personalized outreach to retain those customers. A key feature that supports predictive analytics in Power BI is the integration of machine learning through Azure Synapse and other advanced tools in the Microsoft ecosystem. For organizations willing to go further, you can train machine learning models using tools like Python or R and then integrate the results directly into your Power BI visuals. However, even simple predictive tasks like extending a trend line can reveal hidden opportunities and help businesses prepare for what lies ahead. Once you're predicting outcomes, the final step is prescriptive analytics. This type of analysis doesn't just ask what might happen. It asks, what should we do about it? Prescriptive analytics focuses on optimizing decisions by using insights and predictions to suggest actionable steps. While Power BI doesn't generate specific recommendations on its own, combining it with scenario-based tools and external logic frameworks helps businesses implement prescriptive strategies. For example, say your predictive analytics reveal an upcoming surge in product demand for a specific region. Prescriptive analytics could answer questions like, what's the best way to meet this demand while minimizing shipping costs? You could create a set of what-if scenarios in Power BI using its what-if parameters feature. By modeling variables such as inventory levels, distribution centers, and shipping costs, you can simulate different strategies and identify the most cost-effective approach. Another example is price optimization. By combining predictive insights about customer purchasing behavior with competitor pricing data, you could develop a dynamic pricing strategy to maximize profits while remaining competitive. The ability to run simulations, evaluate multiple scenarios, and see the potential outcomes can completely change the way organizations address challenges. For example, instead of responding to market disruptions reactively, you can proactively decide the best course of action. Power BI's reference lines, what-if parameters, and integration with advanced analytics platforms make it a powerful tool for prescriptive analytics, especially when paired with organizational expertise. Unlocking all 4 types of analytics, descriptive, diagnostic, predictive, and prescriptive, delivers a complete decision-making framework. Each type builds on the insights provided by the one before it, helping organizations not only understand past trends, but act strategically to shape the future. The transition from descriptive to prescriptive transforms analytics from a tool for information to an engine for action, making it possible to anticipate challenges, capitalize on opportunities, and stay ahead of the competition. But to do this successfully, one critical factor remains. The data you're using must be accurate, clean, and reliable. Analytics is only as good as the input it relies on, And poor data quality can undermine your efforts at every level, whether you're summarizing past trends or building machine learning models for prediction. Messy data will skew your results, leading to poor decisions. Fortunately, Power BI includes tools for addressing this issue, like Power Query's data profiling feature, which helps you identify and resolve data inconsistencies before they impact the reliability of your analysis. From column-level profiling to identifying distribution patterns, Power Query makes it possible to prepare your dataset for complex analytics workflows. This ensures every insight you generate, whether it's a bar chart summarizing historical KPIs or a machine learning model forecasting revenue, is grounded in accurate, high-quality data. Clean data isn't just about avoiding errors in visuals. It's the foundation of good analytics and decision-making across the board. As impactful as these analytic capabilities are, clean data is only the starting point for more advanced techniques, like designing optimized data models or leveraging T-SQL queries to uncover deeper insights. Without this foundation, predictive and prescriptive analytics can lead to misleading conclusions. In the next section, we'll see how maintaining data quality plays a pivotal role in turning raw information into actionable insights, while exploring tools and strategies to improve accuracy further. Data quality, the foundation of great analytics. What's the point of analysis if your data is full of errors? No matter how well designed your dashboards are or how advanced your analytics methods might be, the reliability of your insights hinges on the quality of your data. Without clean data, reporting becomes a guessing game. Decisions lose their grounding, and the opportunities you're trying to uncover stay buried under inconsistencies. This is where Power Query's data profiling tool delivers huge value. It's specifically designed to help you identify and address data quality issues before they spiral into bigger problems. Power Query's data profiling tool is like having a diagnostic kit built into your workflow. You'll find it in both Power BI Desktop and the Dataflow Gen 2 environment within Microsoft Fabric, making it accessible regardless of how you're managing your data. To activate it in Power BI Desktop, head to the View tab and enable the column profile option. Once it's turned on, a suite of features surfaces, each one offering detailed insights into your dataset's structure and quality. At its core, the tool works by analyzing each column in your data model, highlighting issues such as errors, duplicates, and missing values. Every column in your dataset gets a quick quality overview presented in easy-to-understand percentages. This overview displays the proportion of valid, erroneous, and empty values within that column, giving you an immediate snapshot of its reliability. For instance, imagine you're cleaning a dataset containing customer orders. When you open the column profile for the customer email field, you might notice that 5% of the values are blank, while another 2% are flagged as errors. These percentages aren't arbitrary. They're direct indicators of how much work the dataset needs before it's truly usable. Leaving these gaps unaddressed could lead to critical insights being overlooked or models producing inaccurate predictions later on. Another standout feature within the data profiling tool is the column value distribution chart. This chart helps you visually understand the spread of values in a column, offering quick insight into patterns or potential problems. For example, the chart displays counts for distinct values. How many unique entries exist alongside unique values, entries that show up only once. This distinction matters because it helps you quickly detect duplicate entries. Let's say your dataset contains a column for invoice numbers. If the value distribution chart shows a high number of distinct values but only a handful of unique values, it's a red flag that duplicates might be present. Duplicates here could mean that some invoices are erroneously recorded multiple times, potentially skewing your revenue calculations or inflating financial reports. The details pane digs deeper, giving you in-depth statistics for each column. Beyond simply showing totals for valid, null, and error counts, it also tells you things like minimum and maximum values, averages, and even standard deviations if relevant. For text columns, the details pane can reveal surprises like inconsistent formatting or unexpected characters. For instance, perhaps your country column includes USA, United States, and US as separate entries. Issues like this might not seem significant at first glance, but they wreak havoc when you try to group or filter data. Identifying inconsistencies here allows you to unify the entries under a single value before they become a bigger problem. Let's apply this to a real-world scenario. Suppose you're preparing a dataset for a sales dashboard that tracks quarterly revenue across product categories and customer demographics. With data profiling enabled, you quickly spot that certain products are missing category assignments and some customer records have invalid age values like 200 or blanks altogether. Using Power Query's tools, you can filter out or replace null values in the category column, ensuring every product falls within a valid grouping. For the customer age data, you can use numerical thresholds to flag implausible entries, setting boundaries like 18 as the minimum and 100 as the maximum allowable age. These targeted fixes might feel tedious, but they massively improve the accuracy and trustworthiness of your final reports. Data profiling doesn't just highlight problems, it also equips you to take immediate action. Duplicate values detected through the value distribution chart, for example, can be resolved by right-clicking within Power Query and selecting options to remove duplicates. Null values can either be replaced with default values or removed entirely, depending on whether they are critical to the analysis. Errors, like mismatched data types, are flagged early, allowing you to inspect and correct them while still in the transformation phase. Let's say your dataset includes a numeric column for sales figures that has a mix of properly entered numbers and text-based errors. Power Query will flag these inconsistencies, and you can choose to correct the errors or filter them out completely, ensuring calculations like total revenue or profit margins remain accurate. Now, why is all of this so important? Bad data isn't just an annoyance. It can have serious downstream effects. Imagine presenting a report based on a dataset that included duplicate sales records. Your report might incorrectly show that quarterly revenue increased when, in reality, it stayed flat or even declined. Worse yet, decisions based on faulty insights can lead to wasted resources, missed opportunities, or even reputational damage. Data quality issues are like cracks in the foundation of a building. If ignored, they grow larger and compromise everything built on top of them. High-quality data, on the other hand, lays the groundwork for robust analytics. When your input is clean and consistent, your descriptive analytics become more accurate. Your diagnostic analysis points to credible root causes, and your predictive models generate forecasts you can trust. For example, say you're building a machine learning model to predict customer churn. If your input data includes duplicates, errors in customer demographics, or blank fields, the algorithm might not just misfire. It could completely miss patterns that truly drive churn. Addressing these issues upfront with Power Query ensures that your models and analytics are built on solid, reliable data. The benefits don't stop at accuracy. Clean data is also easier to work with. Imagine trying to slice and dice a report when key columns contain inconsistent or invalid entries. A clean data set, thanks to Power Query's transformation tools, makes filtering, grouping, and analysis smoother across the board. And for Power BI professionals, cleaner data also means fewer late nights troubleshooting reports that don't make sense. Efficiency is another key advantage of addressing data quality early on. Power Query's profiling and transformation tools aren't just about fixing problems, they're about fixing problems before they cascade. A single blank or incorrect value in a dataset might seem negligible in isolation, but multiply that issue over several transformations, data relationships, or measures, and it grows exponentially into a much larger obstacle. By integrating data profiling into your preparation workflow, you save time, not just now, but also later when scaling your analytics projects. That said, data profiling doesn't operate in isolation. It's the entry point into a broader ecosystem of quality control and analytics tools within Microsoft Fabric. Once you've cleaned and prepared your data set, more advanced tools like T-SQL for custom queries or machine learning techniques for pattern recognition can be layered on top. T-SQL, for instance, takes analytics a step further by letting you query your data for deeper, more nuanced insights that standard Power BI transformations alone might not reveal. Take a healthcare organization, for example. After using Power Query to clean a dataset of patient claims, removing duplicates, filling null entries, and validating claim statuses, you could run advanced T-SQL queries to calculate average claim durations by hospital department. Adding these SQL-derived insights into your report enriches the story your data tells, equipping stakeholders to make better operational decisions with confidence. This links back to why high-quality data is so crucial. Every step in the analytics pipeline depends on the integrity of the data it consumes. Whether it's a simple bar chart summarizing quarterly performance or a complex prescriptive analysis recommending optimal inventory levels, none of this works without clean, reliable input. And while fixing broken data can often feel like the least glamorous part of data analytics, it's the step that makes all the others possible. Power Query, with its data profiling and transformation features, isn't just a tool, it's a safety net. It ensures that no matter how messy or inconsistent your source data might appear at first glance, you have the power to turn it into something usable, trustworthy, and actionable. Addressing those duplicates, missing values, errors, and outliers upfront allows your analytics to shine, providing insights that truly inform decisions. Next comes the exciting part. After profiling and preparing your data in Power Query, you're ready to leverage T-SQL in Microsoft Fabric to dig even deeper. T-SQL can elevate your analytics by enabling advanced querying techniques that go beyond what regular transformations can achieve. In the next section, we'll explore how SQL skills can empower analysts to uncover deeper insights, unlocking even more value from your cleaned and optimized datasets. T-SQL, the power behind the scenes. Can code help you unlock deeper insights from your data? For anyone looking to extend their Power BI and Microsoft Fabric skills, the answer is absolutely yes. T-SQL, or TransactSQL, is the foundation for querying and manipulating data in Microsoft Fabric environments, providing the kind of precision and flexibility you can't always get with visual tools alone. When used well, T-SQL allows you to dive into your data and uncover patterns and relationships that are difficult to spot through other means. And it's an essential skill for more advanced tasks like the DP-600 Analytics Engineer Certification exam. At its simplest, T-SQL is used for retrieving, modifying, and organizing data within the structured environment of Microsoft Fabric. The platform provides distinct environments for working with T-SQL, the Lakehouse, and the Data Warehouse. The Lakehouse is designed for read-only SQL queries, which means it works well for select statements and some data definition language, DDL, operations like creating or modifying tables. On the other hand, the Data Warehouse offers full functionality, including data manipulation language, DML, operations like insert, update, and delete, in addition to select and DDL. Essentially, you can think of the Lakehouse as ideal for exploration and analysis, while the Data Warehouse is built for full-fledged data management and transformation tasks. Let's explore why code-based querying in T-SQL often outperforms visual tools when tackling more complex questions. Visual tools like Power BI's query editor are incredibly user-friendly for general data manipulation, but they come with certain limitations. For example, when you need to run advanced time series analysis, create dynamic aggregations, or join multiple datasets with intricate conditions, visual tools can become cumbersome or insufficient. In these cases, T-SQL shines by letting you craft highly specific queries tailored exactly to your needs, instead of relying on pre-built templates or dragging and dropping options. A good place to start with T-SQL is understanding key functions that drive data analysis. Group by is one of the most widely used, allowing you to aggregate data into categories. Say, for instance, that you're working with sales data from multiple regions. Group by makes it easy to calculate the total revenue per region by grouping rows of data with the same region name and combining their sales figures into a single value. Paired with aggregate functions like sum, AVG, or count, it provides a simple yet powerful approach to summarizing large data sets. For time series analysis, T-SQL introduces even more powerful tools, like the lag and lead functions. These functions create new columns that reference previous or future rows, making them ideal for tracking changes over time. Imagine a table with daily revenue figures for a retail chain. Using lag revenue 1 will populate a column with the revenue from the previous day, enabling you to quickly calculate day-over-day changes. Conversely, lead revenue 1 looks ahead to future rows, making it useful for projecting trends or comparing current performance to projected outcomes. These functions are invaluable when analyzing seasonality, generating moving averages, or investigating spikes and dips in transactional data. Another critical function in T-SQL is row number. This function assigns a unique sequence to rows within a partition of data. For instance, if you want to rank sales branches based on their quarterly revenue, you can use row number along with the partition by clause to segment the results by region. The order by clause then determines how the rows are ranked within each partition. This capability is especially useful for creating leaderboards or identifying top performers within a specific group, such as the most profitable branches by region. Now, let's talk about a feature that makes T-SQL highly approachable, even for those who aren't comfortable typing out queries: the Visual Query Editor in Microsoft Fabric. This tool offers a no-code interface for users to design and execute queries visually, but it still leverages T-SQL under the hood. It works by letting you drag, drop, and configure options like filtering, merging tables, or adding derived columns, and then translating these actions into T-SQL scripts. One of the most exciting things about this tool is that it offers accessibility without sacrificing power, meaning even those who aren't fluent in T-SQL syntax can still perform advanced data manipulations. For example, the Visual Query Editor can simplify tasks like merging tables from different data sources, such as linking a customer demographics dataset to transaction records. Normally, in code, this would require writing a join statement with matching keys. In the editor, you select the two tables, define the relationship between their keys, and the system generates and executes the required T-SQL script. It's a huge help for analysts just starting to gain confidence with SQL concepts, as they can learn by seeing how their actions translate into T-SQL commands. Let's look at an example of using T-SQL to solve a common business problem. Imagine you're a regional sales manager and you need to identify the top 3 performing sales branches for the current quarter. Start by writing a query using the row number function. Here, the query creates a common table expression, CTE, named ranked branches. The CTE calculates total revenue per branch by grouping sales data and uses row number to rank branches within their respective regions. Finally, the main query filters this ranked list to only include the top 3 branches per region. This approach highlights one of the many strengths of T-SQL, its ability to break down complex problems into manageable steps. The with keyword enables you to define temporary result sets that simplify your code, making it easier to create, debug, and iterate on multifaceted queries. CTEs like this are particularly helpful for exam scenarios in DP-600, where modularizing complex logic can save valuable time and reduce errors. But what if you don't feel confident writing this query from scratch? That's where the Visual Query Editor complements traditional T-SQL workflows. Using the editor, you could replicate the same workflow by dragging in filters for date ranges, aggregating revenue by branch and region, and finally applying a sort or rank step, all without writing a single line of code. The Visual Query Editor even offers the option to save these configurations as reusable views, which automatically translate to T-SQL commands when executed. While T-SQL empowers professionals to analyze data with unparalleled precision, some might wonder whether it's worth focusing on code in an age where visual tools dominate. The answer to that lies in flexibility. Visual tools are excellent for standard workflows, but they can hit limits when trying to address unique, highly specific questions. T-SQL is how you break past those limits, allowing you to manipulate data in ways automated tools can't anticipate. From creating multi-step filters to dynamically ranking data, these functions give you the ability to answer questions that visual-only users might struggle to address. And the power of T-SQL doesn't stop with seasoned coders. Remember, the Visual Query Editor bridges the gap, letting non-coders approach SQL concepts through an interactive interface. For teams that include a mix of roles, some technical, some non-technical, the ability to toggle between visual design and raw SQL ensures collaboration remains seamless. Business analysts can experiment visually while SQL developers refine and optimize the output as needed. Ultimately, T-SQL gives you the freedom to explore your data sets deeply, adapt to unique challenges, and customize outputs in a way that visual tools alone can't. Whether you're ranking top sales branches, performing time series projections, or streamlining data workflows across multiple sources, T-SQL extends your capabilities well beyond drag-and-drop analysis. Its versatility shows why it remains a cornerstone skill for analytics engineers preparing for the DP-600 exam and beyond. From understanding basic aggregation to advanced tools like lag, lead, and row number, T-SQL doesn't just give you control over your data, it transforms how you tackle data challenges. When paired with tools like the Visual Query Editor, It's clear that Microsoft Fabric is all about making advanced capabilities more accessible while empowering skilled users to push boundaries. Once you've mastered querying capabilities, it's time to think about how all your tools, from RLS to incremental refresh and performance optimization, come together to transform reporting. Whether you prefer code or no-code workflows, Microsoft Fabric ensures you have the framework to secure your data, scale your analytics, and drive better business decisions. Row-level security, incremental refresh, and optimization techniques aren't just advanced features. They're fundamental tools that make your data work smarter. When your reports only display what users should see, refresh faster with incremental changes, and remain optimized for performance, you create an environment where insights flow effortlessly. These methods protect sensitive data, reduce unnecessary costs, and ensure the analytics process stays efficient. Try these techniques today to secure your data, speed up refreshes, and optimize performance. Start small, but focus on integrating these strategies into your workflows. With practice, these skills can transform your reporting capabilities and give you an edge in advancing your career.